Hi everyone, I'm Nick Handel. I'm the head of data science at Branch International. So, we have a crew from Branch here. That was the group that raised their hands when Toby asked, does anyone know about a feature store? So Branch International is a micro lender. So we lend anywhere from $2.50 to about $1,000 in Kenya, Tanzania, Nigeria, Mexico, and as of a few weeks ago, India. So it's a pretty small company. We have about 9 engineers and 4 data scientists. So we're deploying ML infra at a pretty early stage. But credit modeling, fraud modeling, improving our operational efficiency, it's really all core to being able to deliver loans that are really quite small. And so we really need to figure out how to do that at scale efficiently. So basically the case that I'm going to make is that the feature store is probably the first thing that every company should think about building out as they start to harden some of their machine learning infrastructure systems. So maybe you've heard this. I certainly believe this, but people say that machine learning is 99% infrastructure. I really agree with this. I think that there's a ton of code just on the back end that's doing stuff that isn't actually, it's not the machine learning, it's not the modeling, it's just all of the work that it takes to get the data there, to get the model to train on the right system, and then to deliver that model. Unfortunately, the infra is really difficult. And I think this is the general AI landscape, but there are hundreds of companies with different solutions trying to do a lot of different things. And there are a lot of great ideas in there, but where should you start? Like, how do you start when you first want to deploy a machine learning model? You have a few engineers, you're getting started. It probably looks something like this. It's, you take something that really, maybe it wasn't meant to be used that way, and you take something else and you kind of jimmy it together and you get that first machine learning model out there. There are a lot of great solutions, but there are also, there's also a lot of complexity in just getting that first machine learning model out there. But once you have that going, there's a lot that you can learn from some of the big tech companies that are pursuing some really interesting stuff. So somebody joined the meetup. So I think this is a really great paper. There are a lot of really great papers from Google and a lot of other places that we can all learn from. This is the same one that I think Jim just mentioned. But there's TensorFlow Extended. There's a lot of interesting stuff happening at Google to make machine learning happen. Uber has Michelangelo. There's a lot of really great stuff there. And before I joined Branch, Toby mentioned I was at Airbnb. So I was the product manager for Big Head, and then before that I was the data scientist. So Airbnb's Big Head system, I have an affinity for that. It's a really great system that they've built out. But what about the rest of us? Public solutions are kind of lagging. There's not a ton out there. Big cloud providers are providing these kinds of end-to-end systems, and or they aren't providing these end-to-end systems. I think they have the goal of providing them, but when you really get down to it, when you really look at what it is, it's probably not going to take you the whole way. There really aren't very many enterprise solutions that go end-to-end. I think that this is changing. And there really isn't any widely adopted open source solutions for a lot of this infrastructure. So the option set for the rest of us is to buy various pieces of this and figure out how to kind of glue it all together. And that requires engineering, it requires money, and a lot of these pieces of infra didn't have solutions. I had to change this from don't have solutions to didn't have solutions. So there's a lot, and this I think is really going to change. But feature stores is definitely one of them. And then your other option is to just build. And if you're a company with 9 engineers and 4 data scientists, that is a really, really daunting task. That's a lot of infrastructure that you have to build. So it requires a ton of engineering, and most likely you're going to get a lot of stuff wrong because it's really hard to figure out how your company is going to scale, what's going to change about your team's needs, and you're probably going to have a lot of tech debt. So I think that the general idea of how machine learning happens is kind of agreed upon. If you look at all these different systems, they all kind of have the same pitch. It's extract some data, build some features, train models, serve models, and then monitor those models. And that makes a lot of sense. But data is really at the center of all of those different pieces. So first, you probably have to connect to a range of different data sources. Maybe you want to connect to a Hadoop database. Maybe you want to connect to S3. Maybe you have some other system. Maybe you want to connect to a Postgres follower. Whatever you want to do, there's a lot of different places that you can connect. And most likely you want to validate that data because there's probably going to be a bunch of systems in there that change over time if you're a growing company using machine learning. And so you want to collect features for a variety of different subjects. You probably want to run experiments with models that use different subjects. You probably, especially if you're a business like Branch, where our labels for our loans come in with a very long delay, as long as the loan and maybe even longer than that. You probably want to be able to backfill historical features with some concept of point-in-time correctness. And so what I mean there is that when you go and you backfill this feature, you probably want it to be exactly correct as of the point that you ran inference on the model. And so you definitely do. It's the way that if you're going to go and train your model, you're going to have an accurate representation of the decision that you would have made at that given moment of time. And you probably want to collect and transform features for testing new model ideas. You want to make that really easy. You probably want to make it consistent. You want to make sure that it's consistent between inference, training, development. That's really challenging unless you have some kind of common way of doing this. And maybe you want to share model outputs as features. Have some concept of a learned feature, a feature that is constructed from a model and then input into another model. So, you want to also, potentially cache features to go back and validate your training with your inference calculations of features. Then you probably want to monitor for feature drift, concept drift. So there's just a ton of stuff. You look across this, and along the whole way, you're finding ways to calculate features at exact precise moments of time to monitor it. It's across the entire platform, and that's really, really challenging. And it's pretty obvious that data is just at the center of all machine learning infrastructure, which is incredibly obvious. Of course, it's at the center of all machine learning infrastructure. So the approach that we've taken is to kind of start basic, get something out there, build a feature service. It's basically at the center of all of the machine learning that we're going to do from here. And I think as an early stage company, hopefully we're avoiding a huge amount of tech debt where we just don't know how our features are calculated, or really just slowing down iteration. And then the last bit is just finding ways to mature the pieces of your business that are most important to you. So going into our feature service a little bit, it's probably good to start off defining a feature service. Luckily, I get to go second, so this is far easier for me. But the really simple definition that I have, and actually maybe just to back up a little bit, I think that defining a feature service is really challenging because this is something that pretty much didn't exist not too long ago, and how companies are implementing it at this point is very different. There's no kind of common understanding of what this actually means. But a very simple definition in my mind is it's a service for computing and managing machine learning data. But obviously we have to go a little bit deeper than that. So in order of importance, I think first it's a framework. So what I mean by a framework is it's reusable code. It's the code that actually runs your extraction of data, your transformation of that data, and then the final construction of all of your features. It ensures consistency between training, development, and inference, and it makes it far easier to develop features. You build this framework around how you construct features, and then a data scientist can come in and say, I have a feature idea, and rather than going and writing a long query and figuring out how to pull this and maybe joining it with a bunch of other data, and then writing some chain of transformations, they're just pulling from these already constructed transformations. So second, it's a computation engine. So it's the way that we calculate our features. It's the service that actually runs those. And it's also the ability to go and backfill these new features for old inferences, which I think is probably a varying level of importance to different companies. But I think a lot of companies, it's more important than they understand now. And at the very least, I know that at Airbnb it was really important, and at Branch it's really important. And then lastly, this is core to the definition in my mind, but I think that it's basically the ability to just store features, to reuse them. So just storing the features as you're calculating them in training and then in inference. So at a very high level, this is roughly what we have. Like, this is an incredibly simple architecture, which is probably a good thing for a company with a really small team. But we have a feature repository that is DynamoDB. We have a feature service that is a Flask app that runs some code that I'm about to show you. And in inference, training, and development, we make requests for versioned features that at some specific timestamp. And the feature service basically handles the rest. So you can see that everything reads from the feature service, and then the feature service is writing to this feature repository, and because we're caching all the features there, we can then read it back to the feature service and send it back to inference or training or wherever we want to do machine learning. So the life of a feature. So at the point of inference, this is kind of, in some ways this starts at the end, so bear with me, but at the point of inference, we calculate and cache some feature in production. Then, let's say we go and we decide to iterate on the model. We read from that cache and use those features for model development. Then, during the next training of the model, we also read from the cache and use those features for training. We know that those features are exactly calculated at the point in time that inference was run, and that's a really great thing. And then for feature iteration, we also read all of our old features in so that we can then explore new features to add. So let's say we've explored all of our old features, we've added a new feature, and we want to train with our new feature again. So this time, we have all of the old features were already in the feature repository. It's stored with a key that is the feature name, the inference ID, which is probably like a user or something like that, and the timestamp that we calculated it. And then we will write any new features, so the second version of the feature that we just created, back to the feature repository. Then in the future, all we need to do is just pull all the features that are calculated. And the really hard part there is this train with new features and saving them to the cache, because that requires you to go and actually backfill features for the particular point of time, which is this inference that happened a long time ago. So as a business, we've really prioritized being able to recreate any of our data at any given point in time. And we can then go and validate that by basically running inference and then going back and trying to recreate that exact same feature at some future point in time. So as a business, this is kind of cool. This is a milestone that we just hit recently. We know that we can recreate any feature, any piece of data at any given moment in time for all of our data. So that's a really great thing. This is one of the benefits of being a young company. We can do stuff like this. We don't have to manage a whole lot of tech debt. So how do we actually define our features? So this is very close to an actual example of how we would define a feature. So at a very high level, you can think of an extract, pulling some data, a transformation, transforming that data in some way, and then the feature wrapping together some combination of extracts and transforms. So features are built off of these versioned extracts and transforms. So you can see that everything is versioned as a part of our folder structure within our repo. And everything is built on these abstract base classes. So extract, transform, and feature are all built off of these base classes that have testing frameworks that mean that as we add these in, we're getting testing on top of that. So we can make sure that everything is really accurate. And also, we can make sure that our features aren't changing underneath our feet, which is a really, really terrible thing if you've ever had that happen. And because it's all just Python classes, it's really flexible. You can define constants, you can do your own transformations. I think actually here there's a transformation for email domain. It's some custom transformation that's written into this particular feature, which is selecting some attributes about a user. And you could also loop over some transform if you want to apply it to a bunch of different subsets of your data in some way. So if anyone's ever used Airflow, it's kind of a lot like that, where you can have a ton of flexibility about how you're defining these pipelines. So here, basically, you can see user attributes extract is an extract that goes and probably runs a query against your users table and pulls a bunch of columns. So there are some features. This all gets fed into a pipeline, or there's some data that gets all fed into a pipeline. You can see column mapper, probably that one just takes the user attributes, selects a set of them, and then returns that as a feature. And you can think of this kind of like the feature groups that Jim mentioned. We call them feature families. But you can see that there's here a custom one-off transform for email domains. So this is to basically select the email domain that the user signed up with. And then this is a chain of transformations. So you can see first it takes the time that the user registered at, converts it to a local timestamp, selects some columns from there. So it looks like day of month, day from end of month, a few other time features, and then it adds a prefix to it for registration. So this calculates some set of features. It looks like about, it might be like 15 depending on the attributes column. And so then from your model, you can just go and call this feature and pull all of these features for your users at some given point in time. And I forgot to mention that there's a bunch of flexible methods for merging, joining, concatenating data. It's all pretty flexible. So the reason why we chose Python is it's really approachable. It's fast enough for our inference needs. I think it's really nice, actually. I think a lot of other feature stores are doing everything kind of in an aggregate level, trying to pull a bunch of users at once. Everything here is based on an individual, so you can make a request to the feature store for an individual feature for a user. It keeps it really simple. It's really easy for data scientists to go and write Python, define these features, especially when you can basically go in and write some SQL for an extract and use a bunch of pre-constructed transformations. Everything is versioned, which means it's really easy to manage all of these features at our stage. I think that's probably going to get more complicated down the road. The transforms are all consistent. They're tested. And yeah, so we can use different versions of features for different models. If you already have a model in production that's using an old version of a feature, then you can use that. If you have a new model that you want to use the most up-to-date version, you're not going to break your old model that's in production. The transforms are reusable. They're organized under filter, map, and reduce. And then I mentioned that we have a testing framework, which is great because it means our code works and our production models hopefully don't break. So kind of reflecting back on where we are, we have common feature transformation code that makes it really consistent between training, development, and inference. We are kind of validating inputs. We're at least validating types, and soon hopefully we'll be validating ranges and a bunch of other kind of pieces of data that we want to make sure remain consistent. We're enabling training on much larger data sets because we're just caching everything. So when you want to go and train on 1 million loans, it's really easy to just go hit this cache and pull 1 million feature sets. And that's more about enabling that. There's other infrastructure challenges about training on much larger data sets, obviously. And yeah, we can backfill historical features at specific points in time, 100% of our data. That's pretty exciting. We're sharing model outputs. We're not quite sharing model outputs as features, but that's something that we're kind of evaluating right now. So learned features. And we're storing transform features at the point of inference so that we can then go and validate training. We are starting to track metrics. I think that there's a lot in here. Basically, like monitoring and validation and tracking are like always the last things you do, but they're kind of the most important once you actually get it going. So I think that there's a lot that we can do there. And then everything is in DynamoDB, and we want to make it a lot more accessible to more of the company. It's obviously accessible to the data science team. So my big prediction is that there are going to be a bunch of young companies that are getting going and thinking about how to deploy ML infra early on. And I really do believe that feature stores are going to be the centerpiece of everyone's machine learning infrastructure in 3 years. I think it's going to be at the core. And I think that it's obviously really exciting that we're doing our first meetup ever. This is like a historic moment. That's great. So, big thanks to Dave, who was here. Dave Bernthal, Dennis van der Stee, Spencer Barton, and Ting Ting, who's right there, and then the branch team, who's here to support me. Thank you. So thank you. And then I think we can take questions, or yeah, okay.
I got a question. So oh, sorry, you go first.
So this is, can you translate in plain English what business purpose of backfilling features might be?
Yeah.
In a loan context or a credit score?
Yeah.
Can you just repeat the question?
Absolutely. Okay, what is the business context for backfilling features? So I think that there are a lot of companies who will basically log features in production and then go back and use the logged features. And that's really great if you're YouTube and you have a ridiculous number of visitors coming through your website. You're logging, you create a new feature, you log it for 2 weeks, you train your production machine learning model. That's great. It's really, really difficult if you make loans, and those loans, our shortest loans are 28 days. We have loans that go all the way up to a year. So if we want to create some feature and understand how it's going to impact our loans that are more than 100 days out, if we want to then go and log a feature and try to understand how it's going to impact our model, we have to wait for 100 days, while we collect the label for that signal. And so the business use case is just if you want to do great machine learning and you have lagged labels. At the same time, if you just want to have a much larger data set for your machine learning, it can be really helpful to actually be able to go and create create an entire training sample for a much larger data set. And I think that a lot of companies have the ability to kind of recreate data. There's some kind of logging of how data is changing. but it's not perfect, and so we really prioritize making it perfect, just because it's so core to the success of our business.
Right. Great talk, Dave. You can repeat that for the camera.
Yeah, great talk. Thank you.
No, but so it was on that point, right? Because I mean, you call it backfilling of features from inference, but I would kind of see that as what you're doing is creating new training data.
Yeah.
You want to create new training data.
Right.
And do you see that as a key feature of feature stores, or is it just a kind of byproduct of how you're using them? Because you're obviously an online company, you're getting new data coming. You're getting new data coming in.
Yeah.
The predictions people want to take loans out and so on, and then you get your outcome. Maybe what you said, maybe it's 100 days later or whatever. But is that a key functionality that you see in the feature store, or is it just a byproduct of how you work?
Yeah, that's interesting. So, I would say that the feature store would not be useful to us if we couldn't do that, And so, maybe that's a feature set that, maybe it's a feature that, if it's so core to your business that it actually wouldn't be useful without it, then yeah, maybe it is. I do think it is core. I mean, at least for us, I think maybe other companies, that's a lot less useful. But even in those scenarios, it's so beneficial to be able to go and backfill, data and actually, test your models in the past. I think that there were even teams like the one, the example at YouTube that I was mentioning. There were teams at Airbnb when I was there, where they did that because they could. Search at Airbnb is a great example. It doesn't mean that it doesn't help them massively if they didn't have to do that, right? If you can go and backfill your data and increase your training set, your models are probably going to improve.
Absolutely, I think it's complete. I mean, your online service, your interaction, your data collection is through the online service, so this is perfect for it.
Yeah.
I guess that there are other companies that maybe the data comes from the sensor network or from financial transactions or some other kind of system.
Right.
Where it's very different. But it's something we don't do, but it's something maybe that should be done.
Yeah.
Question? Any questions?
Yeah, so the cloud providers, they can really optimize the infrastructure given that they actually run it.
So the cloud providers, they can actually really optimize the infrastructure given they actually run it.
Right.
What would a end-to-end solution look like to you?
I think an end-to-end solution for me would basically start at what raw data you're storing and end at you have a production machine learning model and it's monitoring everything that's happening, all of the raw data that's coming in, how it's being transformed, how it's being fed into the model, understanding how the model is handling that, like maybe individual inference level understandings of feature importances, like really deep monitoring of that. I think that cloud providers at some point are going to provide this. I just don't think that right now you can jump into a cloud provider and get a real end-to-end solution without piecing a bunch of stuff together. So
The piecing it together is kind of like AWS, their approach is here's what you can build.
yeah.
What kind of like SaaS level services kind of serve what is would be like ideal for you?
I mean, there are a lot.
Which ones are great?
Which ones are great? Like what? Yeah, I'm curious. In like what pieces of that? Because there are SaaS services for kind of every piece of that, right?
So what you're saying is that there are SaaS services for the pieces, but there isn't a player that's really providing something end to end that you're satisfied with.
Yeah, pretty much. I mean, I think that at the very least, before like a year ago, there was no feature store, and so that seems flawed to me. I think that 80% of all machine learning is just collecting data, transforming it. Basically, the first, the majority of what data scientists or engineers today who are doing machine learning say, this is mostly what I do, and this is pretty painful. And so there was no solution for that. And I think that solutions for that are going to really mature and solve, all kinds of use cases in the future. But to me, that's the most important. That's why I'm saying it's so core. Once I saw what it could do to Airbnb, I really, feel like that is so core to how companies should do ML. But there are good pieces that do these other, model serving, model monitoring. There's a bunch of, companies that do auto ML. Like those companies all have, great solutions for very specific pieces. It's just, in my mind, the remaining 20% of what it takes to actually get ML across the line. So, yeah.
Interesting.
Yeah.
Any more questions? Then thank you, Nick.
Thanks. Cool.